Hey everyone, welcome to this explainer. Okay, so look at your phone right now. You probably see that little 5G icon sitting up there in the corner, right? And for most of us, that icon means exactly one thing: faster downloads. But today, we're looking way beyond that whole speed illusion. We're going to dig into the hard data and the actual underlying network architecture to show you that 5G, it's a fundamental transformation of how our world connects. It is definitely not just some marketing gimmick for, quicker video buffering. It is a literal top-to-bottom overhaul of mobile infrastructure.
So let's start with a really natural assumption. Is 5G actually just a faster 4G? I mean, we went from 3G to 4G, our internet got quicker, so it makes total sense to think 5G is just the exact same tech dialed up a notch, right? Well, over the next few minutes, we are going to completely dismantle that assumption using some incredible source data from telecom experts and real-world performance studies.
All right, let's dive right into this. The myth out there tells us that 5G is basically just 4G with maybe slightly stronger encryption tacked onto a bigger data pipe, but the reality, it's wild. Upgrading to 5G standalone requires a complete architectural overhaul. The old structures from the 4G days, totally tossed out. They've been replaced with brand new, built-in security principles and a fundamentally different way of managing data right at the core level.
Now, to understand why this massive overhaul was even necessary, we really have to look at the hidden vulnerabilities of 4G. In legacy networks, your unique subscriber identity, your IMSI, was actually occasionally transmitted over the air completely in clear text, unencrypted. That meant malicious actors could use fake cell towers, you've probably heard of them, IMS catchers, to track your identity, monitor your location, or literally launch impersonation attacks. Our devices were inherently exposed just by connecting to a cell tower. That was a massive foundational flaw.
And this is exactly where 5G acts as a shield. Enter SUPI, or Subscriber Identity Encryption. In 5G, your identity is encrypted by design before the authentication process even kicks off. By using the home network's public key, which is securely stored in your SIM card, your identity is completely masked. This makes 5G incredibly resistant to passive and active interception. It's a direct, engineered solution to that identity tracking problem we just talked about. It's not some add-on, it is baked right into the foundation of the technology.
Okay, let's zoom out to the network core and see how this builds into a much broader philosophy. 4G operated on a perimeter trust model. Think of it like a castle with a huge wall. If you made it past the wall, the network just trusted you completely. But 5G? It uses a modern cloud-native architecture driven by APIs. Those are essentially software connectors, letting different systems seamlessly talk to each other. In a highly connected environment like this, a perimeter defense is entirely obsolete. Instead, 5G architecture forces operators to operate under a radical assumption. You have to assume an attacker is already inside the system.
And that brings us to an absolutely crucial concept: zero trust architecture. Because the 5G core is distributed and relies so heavily on those software APIs to function, it literally cannot afford to trust anything by default. Zero trust means exactly what it sounds like. Every single action, every single API call requires continuous verification, mutual authentication between network functions, and incredibly strict governance. It doesn't matter if a device or a piece of software is already inside the network, it must constantly prove it has the right to be there and the right to do what it's trying to do.
So, how in the world do network operators actually pull this off without just breaking the network? Well, to secure the 5G core and prevent API abuse, they have to follow three essential steps. First, implement mutual authentication, meaning both sides of a network conversation have to mathematically prove exactly who they are. Second, enforce continuous authorization. You're checking over and over again that a process still has permission to run. And third, apply strong encryption across all interfaces using protocols like TLS and OAuth 2. This is the invisible, heavy lifting happening behind the scenes of every single 5G connection you make.
Now, this massive architectural shift isn't just about locking out hackers. It completely changes real-world performance. In dense areas, 4G really struggles. We're talking speeds hovering between 20 to 100 megabits per second, and latency sitting around 30 to 50 milliseconds. But 5G's entirely new infrastructure allows it to thrive in high-density crowds. It pushes speeds over a gigabit per second and drops latency to as low as 1 millisecond. This fundamental architectural difference is exactly why 5G can support advanced, real-time applications without dropping connections the second a crowd gathers.
But hey, abstract numbers are really just theory until we test them under actual pressure, right? So let's look at an empirical study conducted right in the heart of Mumbai, specifically across the bustling, high-density districts of Colaba, Byculla, and Mumbai Central. Mumbai is, without a doubt, one of the most densely populated urban environments on the entire planet. If we want to prove that 5G's architectural improvements actually translate to measurable user experiences under heavy strain, there is literally no better testing ground.
Before we get into the actual results, I want you to keep this number in mind: 3.5 gigahertz. This is the higher frequency band that 5G primarily operates on here compared to 4G's 2600 megahertz. Operating at this higher frequency is exactly what gives 5G the raw physical capability to handle massive population density. It's kind of like adding lanes to a highway. It allows for a wider bandwidth, meaning way more data can travel back and forth simultaneously without getting backed up.
Now, what's really interesting here is that the sheer scale of the difference is staggering. When comparing upload speeds in these specific districts, 5G delivers speeds almost 10 times faster than 4G. 10 times! Upload speed is absolutely crucial for how well a network processes user-generated data. Whether you're sending massive files for business or trying to back up high-res video to the cloud without waiting until your hair goes gray, 5G is just operating in a completely different league.
And honestly, the performance gap gets even wider when the network is under stress. You know that feeling when you're in a massive crowd and your phone suddenly just becomes a brick? Well, while legacy 4G networks completely choke under that peak hour pressure, 5G consistently maintains download speeds above 80 megabits per second in these exact same areas. Just think about what that means for a densely populated city. Even when digital traffic is at its absolute worst, 5G users are still experiencing high-quality, data-intensive stability.
Let's pivot and look at latency. The amount of time it takes for a data transmission to actually start. 5G drops that delay down to a near-instant transmission, and this is basically the holy grail for modern technology. Why? Because you simply cannot have autonomous traffic management or instant environmental monitoring if your network takes 40 milliseconds just to think about it. 5G's ultra-low latency essentially removes the lag from our digital infrastructure.
But it's not just about raw speed, is it? It's about reliability. 5G massively reduces two huge network headaches: jitter, which is that annoying unpredictability in data arrival that completely ruins your voice calls and streaming, and packet loss, where the data just doesn't arrive at all. By flattening both of these out, 5G makes mission-critical applications finally genuinely reliable on a mobile network.
So you might be wondering, how are the local telecom providers actually handling this massive transition in Mumbai? Well, the study shows a pretty clear landscape. Jio is currently leading in speed and coverage, especially in those congested areas. That's largely because their really robust existing 4G infrastructure paved the way for a dominant 5G rollout. Airtel, on the other hand, excels when it comes to consistent performance and overall customer service quality. Meanwhile, Vodafone Idea maintains a very dedicated user base, even though the data shows they trail behind the other two in raw 5G speed. It's a super fascinating look at how different companies are racing to deploy this new architecture. Of course, deploying the tech is only half the battle, right? People actually have to use it, and the demographic data is really telling here. It shows the 18 to 34 age bracket adopting 5G rapidly, which makes sense. It's driven by data-heavy habits like 4K streaming and competitive online gaming. Adoption kind of steadies out in the middle age bracket and remains pretty low for those 55 and older, who generally just rely on 4G for less data-intensive daily routines.
Which brings us to our final thought for today. We've seen how 5G provides incredible, truly transformative performance in complex urban environments. But we also learned that this performance is entirely dependent on a hidden, foundational layer of zero-trust security and API governance. The transition from 4G to 5G, it isn't just a simple upgrade. It's a prerequisite for the future. So as telecom companies begin looking ahead to 6G and even more advanced smart cities, I'm going to leave you with this question. Is your city's infrastructure genuinely ready to embrace the zero-trust reality? Thanks so much for joining me for this explainer. I hope this helps you look at that little 5G icon on your phone in a whole new light.